Hello, Shafruddin, getting my voice?
Yes, sir.
So I have told you today we will discuss the introduction of the vectors. Yeah. So because we should know the basics of the vector because vector will be used in the further chapters. Okay. So that is why I am discussing the vector. So basically, the first question is uh, what is a vector? What is a vector? Actually, there are two types of quantities. There are two types of physical quantities. Physical quantities means quantities which can be measured. Physical quantities. So there are two types of physical quantities. Number one is the scalar. Number one is the scalar quantity, and another vector. So scalar quantities, for example, mass is a scalar quantity. Mass. So time is a scalar quantity. Distance is a scalar quantity. So we do not talk what is the direction of the mass. We do not talk about what is the direction of the time. Okay. So
Sir, your voice is like your whole thing cut out, sir.
mm, hello.
Yes, sir. Your whole thing froze. Your voice froze.
Now it's okay.
No, no, it's okay.
It's not okay. Now it's okay. Okay.
No, it's okay. It's okay.
Okay. Okay. Okay. No problem. So I think there is an issue in my internet. Okay. So scalar quantities have magnitude, magnitude only, no direction. For example, mass is a scalar quantity, time is a scalar quantity, distance is a scalar quantity. Now, vector quantities have the magnitude plus they have direction plus they follow vector laws of addition. They follow, for example, force. Force means whenever we are talking about the force, we talk about the direction also. Suppose I am applying some force on this pen. So means I am applying a force in a particular direction. I am applying a force in a particular direction. So for example, force is a vector quantity, velocity is a vector quantity, displacement is a vector quantity. There are many more other vector quantities that we will discuss. Force, velocity, displacement. Okay. So there are basically two types of vectors. Number one, the polar vectors and the axial vectors. Okay. Polar vectors like mass, time, acceleration, force, velocity, displacement, these are the polar vectors. Polar vectors are the vectors, they act along the straight line, and they have the starting point also. Okay. Okay, so after this we will discuss how we denote the vectors, how we denote the vectors. Okay, so for example, notation, we denote the vector. Suppose it is written a and this sign of arrow, so this is known as a vector. A vector, this is known as a vector. For example, this is force, f is representing force, and this is the vector, force vector. If force vector is written like 10 Newton along east. Okay, so 10 Newton along east. So 10 Newton is the numerical value or magnitude of force, and what is east is the direction. East is the direction. For example, this is the east direction. Okay, this is the east direction, and a body is there of mass m. A force is applied, and this force you are applying of uh, 5 Newton. So you will write, how you will write this thing? You will write force vector of 5 Newton along east. Okay. Now there is a term magnitude. Vectors have two things, magnitude and the direction. So now we will discuss magnitude. So suppose there is any vector a vector. Suppose there is any vector a vector. If you want to find the magnitude, if you want to find the magnitude, then you will write mod of a vector. This is the representation of magnitude of a vector. For example, uh, force vector is this. Okay, and if you want to find the magnitude of force vector, only magnitude of the force vector, so how you will write? You will write force vector, and you will write mod of force vector, mod of force vector. Okay, this is the case. So if it is written that 5 Newton force along north. So if I am asking what is the magnitude, then what you will say? 5 Newton. Magnitude will be 5 Newton. Okay. And how to write this? If this is written like 5 Newton along north. So you will write this magnitude as force vector and modulus equal to 5 Newton. So this is the magnitude of force. Magnitude of force. So now how we represent the vector? How we represent the vector? We represent the vector like this. Means this in the form of the arrow. In the form of the arrow. This arrow have head, and this is the tail. This is the tail. And length of this arrow, length of this arrow represents the magnitude of the vector. So length of arrow gives the magnitude of vector, and arrowhead represents the direction. So if I am drawing an arrow like this, and if I am drawing an arrow like this, okay, so this arrow is going in this direction, and this arrow is going in this direction. Okay, so with the help of this arrowhead, we can define the direction of the vector. So this have something, this have some other direction, this have some other direction. Okay, so for example, this is the direction, each direction is this. Okay, each direction is this. So I am drawing a vector like this. Suppose this is the a vector, this is the a vector. So length of this arrow, length of this arrow from here to here, length of this arrow will be magnitude of a vector, will be magnitude of a vector. And this arrowhead will represent the direction of this a vector, because vector have the magnitude as well as the direction. Okay, vector have the magnitude as well as the direction. Suppose for example, two vectors are there. One vector is this, and another vector is this. Suppose this is your a vector, this is your b vector. Okay, so this is the representation of a vector, this is the representation of b vector. If I am asking which vector have the more magnitude, a vector or b vector? Shafruddin.
Yes, sir.
I'm just asking. I'm just asking
The
which.
magnitude, right?
Yeah. I am just asking only the magnitude.
B.
Yeah. No. Not B. Magnitude of A will be greater, because this length of the arrow is the magnitude of the vector. Okay.
Okay.
So length of this arrow, na, here will be this a vector like this. This is the magnitude of a vector. Okay,
Yes.
and this magnitude of a vector will be greater than magnitude of b vector, because you can see the length of a vector is greater than length of v vector. Okay.
Okay, sir.
Okay, so if two vectors are like this, suppose this is one vector, uh, suppose this is your a vector, and suppose this is your another vector, b vector. Suppose this direction is the right direction, and this direction is left direction. Okay, so if I am saying that this vector have the direction,
Yeah.
a vector have the direction,
A is also greater, right?
yeah, a vector have the direction right, and b vector have the direction left. So how we are able to distinguish the direction? Because of this arrowhead. This arrowhead is representing the direction. And if I am if I will say which vector have the more magnitude, which vector have the more magnitude, a vector or b vector?
A.
Yeah, because length of arrow of a vector is greater than length of arrow of b vector. So magnitude of a vector is represented like this. Magnitude of a vector is greater than magnitude of b vector. Okay, and magnitude of a vector or b vector is represented like this also. You can either represent the magnitude of a vector like this, or simply you can write a, or simply you can write a. Okay, or simply you can write a. So what is this? This is magnitude of a vector, magnitude of a vector, magnitude of a vector. Okay, now we will discuss some basic vectors. Okay, now we will discuss some of the basic vectors we have. Some basic definitions. Some basic definition we will discuss. Number one. Number one, we will discuss equal vectors. We will discuss equal vectors. We'll discuss equal vectors. So what are equal vectors? Equal vectors. Equal vectors means when two vectors will be equal, when the magnitude of those two vectors and the direction will be same, like this. One vector is this and another vector is this. Okay. So this vector have this direction, this vector have this direction. Suppose this is your A vector, this is your B vector. So for equal vector, the magnitude as well as direction should be same. The magnitude as well as direction should be same. So you can take this case also. Okay. So here in this case, A vector and B vector are equal vectors. Okay. So A vector and B vector are equal vector. Why A vector and B vector are equal vector? Why I am saying equal? Because the length of the arrow of A vector and the length of the arrow of the B vector means the magnitude of A vector and magnitude of B vector is equal. Direction is same. Here also magnitude and direction both are same. That is why these vectors are equal vectors. Okay. So you can write here your magnitude of A vector is equal to the magnitude of B vector, or you can write A equal to B. Okay, and direction same. Slowly you will get slowly. Okay, so equal vector. Now number second, negative vectors. Negative vectors. Negative vectors have equal magnitude and opposite direction. And opposite direction means you can take this case. These two vectors, this is A vector, this is B vector. The length of the arrow of A vector and B vector is same, but the direction is opposite. Okay, this can be the case. A vector and B vector.
So is it equal or?
No, these are the negative vectors. Equal vectors mean have the same direction, have the same magnitude. Negative vector means have the same magnitude, but direction is opposite. Okay.
Oh, okay.
So in between the equal vectors, angle between the two vectors that is equal to 0 degree. And in between the negative vector, the angle between two vectors is 180 degree. Now, number third, parallel vector. Parallel vectors. Parallel vectors means you can say this can be the example of parallel vector. Two vectors have same direction are parallel vector. This is your A vector, suppose. This is your V vector. Okay, so parallel vectors have same direction. This vector or this vector, these vectors are parallel also. Okay. Have same direction only. Suppose, for example, if a vector is like this and another vector is like this, these vectors are also parallel vectors. Another anti-parallel is opposite of parallel, opposite direction. Anti-parallel vectors. Anti-parallel means one vector will be like this and another vector will be like this in opposite direction. This is A vector, this is V vector. This can be the case. A vector and V vector. This can be the case. A vector and V vector. Anti-parallel vector have opposite direction. And if the vectors are anti-parallel, angle between two vectors means anti-parallel means the vectors have opposite direction. So you can say the angle between the vectors theta will be 180 degree if two vectors are anti-parallel. And if someone is asking what will be the angle between the two vectors, then you will say angle between the two vectors will be 180 degree. Okay. Shafuddin, are you getting?
Yes,
Hello.
sir.
Okay. My voice is okay now?
Yes, sir.
Okay, okay. Now coplanar vector. Number 5. Coplanar vectors. Coplanar vector means this I will explain with the help of one example. Vectors lying in same plane. Vectors lying in same plane are coplanar vector. Means suppose this is some plane. Okay. This is not visible. Okay, so what I am doing, this screen, your screen is a plane. Okay, your screen is a plane, and the vectors on your screen will be the planar vector. Okay, suppose this is my this is some plane. This vector, this vector, this vector, all vectors are planar, but this vector will not be planar. This vector is perpendicular to this plane, so this vector is not planar. Okay, so vectors acting in same plane, coplanar vectors. Vectors acting in same plane. So screen of your laptop is a plane, or screen of your phone is a plane. So I am drawing the vectors on the screen. Suppose this is one vector, this is another vector, this is another vector, this is another vector. So all these vectors, A vector, this is V vector, this is C vector, this is D vector. All A, B, C, D vectors are coplanar vectors. A, B, C, D vectors are coplanar vectors because they are lying on the plane of your screen, on the same plane, or on the same plane. So A vector, B vector, C vector, and D vector lying on same plane. Number six, co-initial vector. Co-initial vector. Co-initial vector. Co-initial vectors are the vector having same starting point. For example, one vector is this. This vector is started from this point, and another vector is this. Okay, suppose this is your A vector. This is your B vector. Suppose this is another vector, C vector. So this is the starting point now. So these are the vectors. These are the vector co-initial vectors are the vector having the same starting point. Okay, vectors have same starting point. Vectors have same starting point. So co-initial vector. Now seventh is important, unit vector. Unit vector. Unit vector is a vector having unit magnitude, having unit magnitude and any direction. Means the condition is this unit vector have the uh, unit magnitude, and direction can be any direction. For example, if we have a vector, this is a vector. Okay, if I want to write the unit vector of a vector, okay, if I want to write the unit vector of a vector, then how I will write unit vector of a vector is equal to, this is written like this, a and this a cap. So a cap, this is the unit vector of a vector. Okay, for example, a vector n cap. So what is this n cap? N cap is a unit vector. N cap is a unit vector. Okay, this n cap can be in this direction also. So this n cap, cap is representing the unit vector. Okay, and when you will calculate the magnitude of n cap, or when you will calculate the magnitude of minus n cap, this will be equal to 1. So magnitude is unit, mean magnitude is 1, and direction can be any direction. Okay, so suppose you have a vector, a vector, and you want to find the unit vector of that a vector. Okay, unit vector of that a vector. So unit vector of any a vector. So how we represent the unit vectors? A cap. So unit vector of a vector will be, first you will write a vector divided by magnitude of a vector. This formula you should know. Now there are the universal unit vectors. Universal unit vector, very important, very important. Universal unit vectors. Universal unit vectors. Very important. Remember. Okay, so what I am doing? I am taking. Oh, sorry. Axis. X-axis, Y-axis, and Z-axis. I am taking. So this is our x-axis, this is our y-axis, and this is our z-axis. This is our negative x-axis, this is our negative y-axis, this is our negative z-axis. So please remember, this is very important point. Universal unit vectors are represented by I cap, j cap, and small k cap. Small I cap, small j cap, and small k cap. Or universal unit vector will be can be written minus I cap, minus j cap, and minus k cap. So a unit vector acting along x direction, a unit vector acting along x direction is I cap. A unit vector acting along y direction, negative x direction is minus I cap. A unit vector acting along positive y direction is j cap. A unit vector acting along negative y direction is minus j cap. A unit vector acting along positive z direction is k cap. A unit vector acting along negative z direction is minus of k cap. Minus of k cap. So basically, these are the unit vectors. And what is I cap? I cap is the unit vector along x-axis. If I am writing minus I cap, so you will say unit vector along negative x-axis. Okay, I cap, j cap is the unit vector along y-axis. If I am writing k cap, small k cap, so this will be unit vector along z-axis. Unit vector along z-axis. Okay, so all of these unit vector have the magnitude equal to 1. I cap have the magnitude equal to 1. J cap have the magnitude equal to 1. K cap have the magnitude equal to 1. And minus I cap equal to minus j cap equal to minus k cap magnitude is equal to 1. Okay, so universal unit vectors are very important. Okay, for example, and why we are defining the universal unit vector, these universal unit vectors helps us to define the direction of any vector, to define the direction of any vector. For example, if it is written force vector of 5 of I cap, force vector of 5 of I cap, then what you can say, and this is written as 5 I Newton. So what you can say, 5 Newton is the magnitude of the force, and I cap is representing the direction. So what about the direction? Direction, you will say this force is acting towards x axis, along x axis, along x axis. If it is written like this, force vector of minus of 3 k cap, minus of 3 k cap. So Shafruddin, tell me what is the magnitude of this force and what is the direction of this force. Apply your mind here. And I have told you, I have told you. Hmm?
Direction of 4.
Direction is?
Of 4 will be up.
No. You have to tell me the direction with respect to x-axis, y-axis, and z-axis. Okay.
So direction will be
okay.
y-axis.
Y-axis, right? Okay. So negative y-axis or positive y-axis?
Positive.
No. Negative y-axis. See how we have to write. Remember that. This point you have to remember. Magnitude cannot be negative. Magnitude always be positive. Magnitude can never be negative. Okay, so this is the case given. This is the case. Minus 3 I cap. So I can write this as na 3 into minus k cap Newton. So this 3 is the magnitude. And what is the magnitude? 3 Newton. And minus k cap is representing the direction. So what is the direction? Negative z axis. Negative z axis. Okay, negative z axis. So take the screenshots. This is very basic lecture. Today is very basic lecture about the vectors. Okay.
Done, sir. Done, sir. Done, sir.
Done. Okay.
Done, sir. Done, sir. Done, sir. Done, sir.
Okay.
Done, sir. Done, sir.
Hmm.
Done.
Done. Okay. Good. Now, uh, representation of vectors. We basically represent the vectors in polar form or in Cartesian form. So one by one, I am explaining. One by one, I am explaining. So representation of vectors. So vectors can be represented. Number one in polar form. Number second in Cartesian form. So first we will discuss the Cartesian form. First we will discuss the Cartesian form. Cartesian form. Cartesian form means suppose a vector is written like this: a1 I cap plus a2 j cap plus a3 k cap. Means in Cartesian form, this is I cap. What is I cap? I cap is the unit vector along x-axis. What is j cap? Unit vector along y-axis. K cap unit vector along z-axis. So in Cartesian form, the vector can be written in terms of the unit vectors along different axes, along different axes. Okay. And what is a1, a2, a3? A1, a2, a3. A1 is the component of a vector. A1 is component of a vector along x-axis. What is A2? A2 is component of a vector along y-axis. What is A3? A3 is component of a vector along z-axis. So A vector can be written in this form. If you want to find the magnitude of A vector, so we represent magnitude like this, mod of A vector. So magnitude of A vector, if you want to find, then what you have to do, you will write A1 square plus A2 whole square plus A3 whole square. Okay. For example, if A vector is written like this, 5 I cap minus 2 j cap plus k cap, and you want to find the magnitude of A vector, then how you will find it? You will find like this: 5 square plus minus 2 square plus 1 square. Okay, you will get the answer. Now, one question: 5 square means you will take this 5 square, you will take this minus 2 square, you will take this. Here is k, means you can write this as 1k. So you can write 1 square. So one question I'm giving: A vector is written like I cap minus 3 j cap plus 2k cap. We have to find A cap, means unit vector of A vector, and magnitude of A vector. This we have to find. So okay, after this I will give you the question. First I am solving, then after that I will give you a question, then you should solve that. So this is the A vector given, and A vector is given in terms of the unit vector I cap minus 3 j cap plus 2k cap, and A vector A cap we have to find, means the unit vector. So for the unit vector there is a requirement of A vector. So we have the A vector. Now there is a requirement of magnitude of A vector. So we do not have magnitude of A vector. First we will calculate the magnitude of A vector. So how we calculate the magnitude of A vector? Coefficient of I cap square plus coefficient of j cap square plus coefficient of k cap square and under root. So coefficient of I cap square is 1 here, 1 square, plus coefficient of j cap square, coefficient of j cap square is minus 3 here. So minus 3 square plus coefficient of k cap square is 2 square. So this will become root 15. Root 15. Okay. This will be. So if you want to find the A cap, then you can write the A vector divided by the magnitude of A vector. What is A vector? A vector is given this I cap minus 3j cap plus 2k cap. So this is I cap minus 3j cap plus 2k cap divided by root 15. So this will be your A cap, unit vector of A vector. Okay, this will be your unit vector of A vector. Okay, Shafruddin, I am giving you one question and you should try this. Uh, Suppose P vector is given as 5 I cap plus j cap plus 3 k cap. Okay, you have to find unit vector of P vector and magnitude of P vector. You have to find and just tell me the answer. Try it by yourself. You can take the help of this question. Just solve this.
Is the answer root 35?
Answer of this P cap means unit vector of P is, what is this value you are getting, or what is this value you are getting?
P cap is root 35.
No, p cap will not be root 35. It will be this, na. First you have to find the
Oh,
magnitude, na. It will be this. Basically, just a minute. Actually, you are getting confused here by the symbol. P cap is the unit vector. P cap is unit vector, and this is the magnitude. Now try how to find the unit vector. Unit vector can be find it out. Just okay. Wait. I am solving. No problem. See, we want to find the unit vector, na. So unit vector of p vector is given by first p vector divided by unit vector of p vector, magnitude of p vector. P vector divided by magnitude of p vector. Okay. Now what is p vector? P vector is this 5 I cap plus j cap plus 3 k cap. Okay. Now we do not have this p magnitude of p vector. So how to calculate the magnitude of p vector? We can find with the help of 5 square plus 1 square plus 3 square. 5 square plus 1 square plus 3 square. So this will become 25 plus 1 plus 9. This answer was right of yours, 35. So now p cap if you want to find, na, so you will write here. If you want to find the p cap, na, so what you will write? You have to put this 35 here. Here you have to put this 35.
it's L plus J plus K by root 35. Oh, okay.
Yeah, 5 I cap plus j cap plus 3 cap divided by root 35. Okay,
Yeah.
or you can write this like this also, 5 by root 35 I cap plus 1 by root 35 of j cap plus 3 by root 35 of k cap. Okay, simply you can write this also. Okay, now there is one addition and subtraction of the vectors. Addition and subtraction of the vector. Addition and subtraction. Subtraction. In Cartesian form of vector. So suppose a vector is a1 of I cap plus. Okay, I am telling you this directly. I am not wasting time. I am telling this you directly. Okay. Suppose, for example, suppose this is your a vector. A vector is I cap plus 2 j cap plus 3 k cap, and your b vector is 3 I cap plus 5 j cap plus 9 k cap. If you want to add a vector plus b vector, then what you will do? You will just add this 3 I cap plus I cap, 4 I cap plus 5 to 7 of j cap plus 9 3 12 k cap. Got it? This is the addition.
Yes,
This is addition. I am just trying to explain you in a very simple way. Subtraction, for example, if you want to subtract a vector minus b vector, if you want to subtract a vector minus b vector, suppose if you want to subtract a vector minus b vector, then how you will do? You will write this is I cap, this is minus 3 I cap. So here will be minus 2 j I cap minus 2 I cap. This will be minus 2 I cap, and this is 2 j cap minus 5 j cap will be minus 3 j cap. Okay, this is 3 minus 9. 3 minus 9 means minus 6 k cap. Okay, so this is your addition. This is your addition, and this is your subtraction. Okay, one question I am giving. P vector is given as I cap minus j cap plus k cap. Q vector is given as 3 I cap plus 5 of j cap minus 3 of k cap. You have to find p vector plus q vector. You have to find p vector minus q vector. Okay, just Shafruddin, try it by yourself first. Very simple. This is very simple.
Four I plus four J
Mhm.
minus two K cap for P plus Q.
Okay. What is the answer? What is the answer? Okay, now I am solving. Have you completed p minus q?
Yeah.
Okay, so now you can check your answer by yourself. Okay, I am just solving. So first answer p plus q, p vector plus q vector. So p vector plus q vector will be I cap plus 3 I cap. This is 4 I cap. Okay, j cap. So this is minus j cap. This is 5 plus 5 j cap. This will be 4 j cap, 4 k cap. This is plus k cap. This is minus 3 k cap. So this will become minus 2 k cap. And p minus q will be I cap minus 3 I cap. I cap minus 3 I cap will be minus 2 I cap. This is minus j cap and minus j cap and minus 5 j cap. This will become minus 6 j cap. K cap and minus 3 k cap. K cap minus of minus 3 k cap will become 4 k cap. Okay. So in this way you can calculate. Okay. I think it will take one more class to complete this vectors. The basics of vector I am just telling. I am not going in detail. So that when we will study the work power energy, when we will study Newton's law of motion, when we will study another chapters, there all these things will be used. All these things will be used. Okay. This unit vectors will be used. Okay. This unit vectors will be used, and this Cartesian form will be used. You should know how to add two vectors. You should know how to multiply two vectors. Okay, you should know how to add two vectors given in the polar form. Okay, so all these things will be required. All- okay, now you can take the screenshot from here now. Okay, this will be completed now. Take the screenshot from here. Then okay. Okay. So one last question I am giving. Just try to solve it. Okay, and tell me the answer. Uh, one last question I am giving. P vector is given 2 I cap minus 3 j cap plus k cap, and q vector is given as 2 I cap plus 3j cap plus 2k cap. You have to find magnitude of p vector, unit vector of p vector, and you have to find p vector plus q vector, and you have to find p vector minus q vector. Just write and tell me the answer. Okay, Shavaluddin, see here. This is the magnitude of p vector. So how we will calculate the magnitude of p vector? See here, this is 2 square here, coefficient of I square,
Root 40.
root 40, okay, plus minus 3 square plus 1 square. So it will become 2 to the 4 plus 9 plus 1 root 14. Very good, root 40. Now another, we have to find the unit vector of the p vector. Unit vector of p vector is given by p vector divided by magnitude of p vector. We have the p vector 2i cap minus 3j cap plus k cap divided by root 14. This will be your answer. Another, they are asking p vector plus q vector. Very easy, very easy. So p vector plus q vector, 2i cap plus 2i cap means 4i cap. Okay, minus 3j cap plus j cap means 0 k cap, 0 j cap. Okay, so I am not writing 0 j cap. Okay,
Then 3
so
K cap.
yeah, and plus k cap and plus k cap, 2k cap. This will become plus 3k cap. Now another, they are asking p minus q, p vector minus q vector. This is also very, this is simple, just subtraction. This is simple subtraction. This is 2i cap and this is minus 2i cap. Gone, gone. This is 2i
Minus
cap
6K
and this
cap.
is minus 2i cap.
Minus
Yeah,
K cap.
this is very good. Minus 3j cap and minus 3j cap, minus 6j cap. Okay, and this is k cap and minus 2k cap means minus k cap you will get. So this will be your answer. Okay, so we will continue in the next class, and in the next class, in the half of the next class, I will finish this. Actually, I want to tell you there is one vector law of addition, that is triangular parallelogram law of vector addition, and that is very, very, very important. Okay, in the last classes we have done now. In the last classes, suppose here we have done. Here we have done here. Here we have done this. This acceleration is tangential acceleration, and this is the centripetal acceleration. Both are perpendicular. Then how we will get this result? How we will get this result? Basically, this is the result we get from the vector law of addition, and that is from parallelogram law of vector addition. Very interesting. Okay, here I have just told you, do this and do that. Okay, there I will explain you properly why this is the result, why this is the result. Okay. Actually, this is a special case of law of vector, when two vectors are acting at some angle theta, and in this case theta becomes 90 degree. That is why you will get this result. Okay, so in the next half class we will finish this basics of the vector. I am not saying I am just teaching the whole chapter to you in a very detailed manner, but I am just telling you the basic things that will be required